water out in that cold area. So now sprinkler operates, we get that air evacuating out of the system until we get to a certain point where we break the differential in this old guy right here, and I'm pointing at the valve, not me, but and it trips the valve. So you guys have probably seen a lot of different differential valves, just like our Model D here, right? Just a conventional differential valve, and this Model D valve has actually been in our lineup for about 50 years now. All right, same body that we've had from day one. We've streamlined some of the components on the inside. Basically, instead of, you know, when you replace the clapper gasket, for instance, back then, you know, you had the clapper gasket, you had a sealing ring, then you had all the extra screws and all. Now, if you buy that, it's all basically they bond all that stuff together. So it's one piece instead of 6 pieces now, and so it's a little bit more streamlined. And the rubber parts, when you look at the clapper gaskets of yesterday versus what we're seeing all the valves today, you know, now it used to be all rubber, and now they're, you know, EPDM, basically the same materials that's used for the groove couplings, so they last a lot longer. They don't dry out and crack, much better, right? So, but a differential valve, everybody know how that works? Understand that principle where you've basically got the difference. You know, we've got that big old dinner plate clapper in there, and you know, it's huge, literally, and that's to get the difference, and that's how the differential works. So you've got the difference in surface area. The air is pushing down on the top side of the clapper, and water's pushing up on the bottom side, and for every 1 square inch that the water is pushing up on, the air's got 6 square inches to push down on. So that's where the difference comes in, the differential, 6 times more surface area. So basically, if you've got 6 pounds of water, that means 1 pound of air pressure would hold down that clapper. All right, and that's, you know, the minimum trip point. So if you're looking at 60 pounds of water pressure, and I use that, I know we're more than that today, but I don't have those numbers in my head. I have 60 and 10. So 60 pounds of water pressure pushing up on the clapper, you know, 10 pounds of air pressure is going to push down on the clapper, but that's the minimum trip point. We can't walk away from it that way just because NFPA won't let us, and you like to sleep at night, all right? Because any little fluctuation, one way or another, hopefully it's more air pressure, you have a drop in water pressure, all right? But if you had a little surge in water pressure, it's going to break the differential and trip the valve. So you have a safety pressure on top of that 10 psi, all right? NFPA 13 says 20 pounds unless we tell you different as a manufacturer, and we do. You know, for 60 pounds of water, you're going to be running about 24 pounds of air pressure instead of 30, all right? So it's a great idea. You know, I like to say it's reliable technology, and I do have a reliable shirt on, but it was a little chilly for this guy this morning, so I had to have a sweatshirt on, all right? But, you know, the downside to a differential valve, and it doesn't matter who made it, if it's us, some of those other guys, you know, if you have anything that breaks that differential will trip the valve. So ideally, if the sprinkler operates, you lose air pressure, right? But if you have a water hammer or a pressure surge from a fire pump kicking on, a fire hydrant getting shut down too fast, anything like that, that differential gets broken, it can false trip this valve. So that's the downside, all right? So if you go to the new technology, that newfangled stuff, and you know, this cutaway valve here is our DDX valve. Have you guys ever installed one of these?
Worked on them.
Worked on them? Okay. So, and we'll go through that, because I'll stand between the two then. So our DDX valve here, and this valve on my right hand over here, your left, is called our EX valve. All right, it's our newest dry pipe valve, and we've had the EX out for, shoot, I'm going to say a year and a half, maybe 2 years now. But the DDX came out, like I say, 10 years ago, all right? From the DDX valve, DDX stands for dry, deluge, externally reset. Does anybody know how to reset one of these things? What the first step is you got to do?
Drain.
Huh?
Come on.
Socket, and you know, you take off the faceplate, which technically is an external reset feature because it's on the outside of the valve, right? Right. Just a few more steps. You got to pull the faceplate off. You get your hands in there. You set the clapper down. Give it a good wiggle to get it down to this home spot. Yeah, you know, this one's nice and clean. All right. Put the faceplate back on. All right. This valve requires priming water, so you add the priming water and then you pressurize the system with air and finish opening up your control valves and set the valve up. All right. With the DDX and then the EX valves, you know, they are both low pressure systems versus a standard differential system, but all of them have an external reset feature on it. All right, and you can't see it from the front of the valve because you're going to have to reach around the back side of the valve with your left hand, and it's on the lower left-hand corner of the valve body as you're looking at it. And it looks just like this. It's threaded into the valve body, right? And when it's threaded into the valve body, it's not attached to anything but the valve body, the reset knob itself, right? And we use a different style clapper and seat assembly in the EX and the DDX valves, and it's called a latching style, all right? And you can look at this and say, but Scott, you know, and not this salesman, but I have had salesmen say, but this one's latched open, so that's a latching style clapper too. But it's not. It's latched open. But when we talk about a latching style clapper, it's a clapper that we latch in the closed position. All right, so we're not just relying on a differential principle. Because if you look at this seat in clapper assembly, and this is actually out of these small body valves here. You know, you look at the water surface area that you've got, and a good example is just looking at the clapper gasket. There's two rings here, and you look at the inner ring, and that's your water seal. And you look at the outer ring, that's your air seal. And boy, you look at that and you did some math on that, and it's not very much of a differential, right? And it doesn't have to be, because we're going to use this latch to keep the clapper shut, right? Because if you do the math on this 4-inch valve here, on the clapper itself, the water surface area that's pushing up on the bottom side of the clapper is 7 square inches, okay? The air side, the top side of the clapper is 42 square inches. All right, that's why how much of a difference there is. It's not that much on this little valve here. All right, but I want to talk about, you know, there's actually two reasons that we have the latch on there, and the latch is spring loaded as you're seeing it here. Okay, and the least important reason is to keep the clapper open. All right, when the valve's been tripped and you shut down, because in the set position it's sitting just like this, all right? But when the valve tripped, because it was supposed to, the clapper's pushed out of the waterway, and as the water's flowing into the system, the clappers is by design, it's out of the waterway, so it has very good hydraulics, it's straight through design. But when you go out there and shut the water supply off, and water quits pushing the clapper open, gravity takes over, and the clapper drops down on the latch. And that's why we have the spring on there, is to make sure the latch gets in the way of the clapper. Because that way, next step, you shut the control valve off, you open up the main drain. That way the water that's trapped in your system piping can flow past the latched open clapper through your main drain, right? And NFPA requires us to have that main drain below the clapper so you can do main drain tests, right? When the systems are set up. Because if we didn't do that, like, you know, and I won't bash the competitors, because is their design better than ours? I'm paid to say it is. Ours is better, but in reality, you know, it's what's your preference. But if you've ever been out there and you're looking at a valve, wonder why they have 2 main drains and that other guy's only has 1. And the reason ours only has 1 and theirs has 2, and there's a couple other manufacturers out there that have 2 main drains. The one that's down here below the clapper is required by NFPA 13, but they have that second one on top side of the clapper because when their valve, you shut the water supply off, their clappers reset. All right, that traps all the water in their system. So they have to have that second main drain above the clapper to drain the system. Just
That wouldn't be Victaulic, would it?
well, they'd be one of them.
Is that a question?
Well, I was just wondering what other
Vikings does
Viking?
that too. Yep.
2
Yep. And depending on
the newer valves.
on their new, most of Vikings do. Yeah. On their deluge type valves. Yeah, and then when you look at, you know, I don't want to say 4-letter words, and Tyco is a 4-letter word at Reliable, but when you look at their valves, their DPV1, their dry valve, which is a standard differential dry valve, it does have an external reset feature, but it's just a conventional dry pipe valve, right? When you go into their deluge valve that you can do deluge or pre-action systems with, the DV5, that one, it's a diaphragm style valve, so they've got the main drain below the diaphragm, but then they also have one on the top side. Actually, there you have to have a system side check valve. So basically like a riser check valve on the top side of that valve, and that's where your second main drain is. So the clapper's latched open, but we're not going to make you take the faceplate off because we've got this external reset now, all right? So all you got to do is reach around the back side of the valve body. We'll latch this guy up here. All right. And if you look at the reset knob shaft, you're going to see that groove that's machined into the end of it. And if you look at this hinge pin where that latch is, all right, just like little wrench flats machined onto it. So what you have to do is you're going to reach around, you're going to compress this spring, moves the reset knob shaft into the valve body itself, and you're going to feel it butt up against that reset knob or that lever shaft, and then you're going to spin it. Remember, you're looking at it like this way. You're going to spin it counterclockwise. And when you're going to do that, you're going to feel the two engage with each other, and you just keep turning it, and it won't go any farther once you're engaged. All right. And the lever gets moved out of the way. The clapper drops down on the seat. All right, and then you just let go of the latch or the reset knob, and it works much better when it's installed in a valve because it's not in two pieces in Scott's hand. So we're latched open here. It's just as easy as that. You let go of the reset knob, it disengages. You've got, or you've worked on some of these someplace here?
Yeah, the Aspen Hospital's got 3 of them.
Oh, cool. Very cool.
They're bigger, of course, but
Yeah.
same valve.
Yeah, and that's a good point too. You know, if you look at our conventional Model D valve, 4 and 6 inch. That's your two choices. All right, and that's flange by groove or flange by flange only. All right, when you look at the DDX and the EX valves, you're looking at 2, 2.5, 3, 4, 6, and 8. All right, standard is going to be groove by groove ends on all those sizes, but on the 4 and 6 inch we offer flange by groove or flange by flange options, and the 8 inch we offer a flange by flange option. And you know, when you look at, this is actually a stainless steel model. They're really pretty, super sport models, so I like to call them here. But that's a 4-inch one. All right, that 4-inch DDX valve, and all the takeouts are the same as far as the different sizes. All right, well, it's 14 inches, end of groove to end of groove. When you look at it, if you're going to go out and replace an old Model D drive valve, for example, that 4-inch flange by flange or flange by groove is going to be 16 inches. Well, you know that 14-inch piece is going to fit in there, but now you got a 2-inch gap you got to make up somehow. Either recut your riser, or you know, if you can get somebody to fab you a little 2-inch groove by groove piece, make that fit. Good luck. But what we did when we, you know, if you go with that flange by groove option because you're going to replace like an old Model D, we stretched the takeouts 2 inches for the 4-inch, and basically the 6 inches the same way. It's a little bit higher. Those are 19 inches, but basically stretched them out so they match the takeout. This is the designer coming out in me, okay? All you got to do is slide this one out, slide the new one in. It's easy as that, right? Work good on paper.
Always.
Maybe not so much in the. Maybe there was a little hiccup. You know,
Maybe the rider falls half-inch.
yeah. So, any questions so far? All right. So now we've got the clapper reset. Okay. It's sitting there just like that, and that spring there, that spring is not strong enough to hold that clapper down when we put water pressure underneath the clapper. All right. So what we're going to do is we're going to have a helper, and our helper is this pushrod chamber, and all of our DDX and EX valves have the pushrod chambers. And as you're looking at the valve, like you guys are, on the left-hand side of the valve body is our pushrod chamber. And I'm going to take a minute and go to the right-hand side of the valve. And when you look at the DDX systems, all right, the alarm trim on the right-hand side, whether it's the actual alarm line, which is the upper line here, or the alarm test line, which is the lower line, is all the same on any of the systems that we build. And we want to, we've got actually some valve posters for our DDX valves too. If you guys would be interested in 1 or 4 of them, I don't, you know, it doesn't matter. Just to remind Michael to grab them for you if you'd like them. But that's all the same on any of the valve trims. So we build low pressure dry systems, deluge systems, and pre-action systems. Different actuation methods. For honestly, it's a total of 10 different systems that we build with just this DDX platform. The alarm's all the same. The alarm trim on the right-hand side is all the same on the DDX system. The EX is a little bit different because we just changed that. We streamlined the trim a little bit, made it narrow, right? But on the left-hand side, it's all going to be the same too, with the pushrod chamber. All right, this pushrod chamber, basically, this is the internal components of the pushrod. All right, we've got a diaphragm assembly that makes a water seal between the pushrod chamber itself and the valve body. All right, then there's the pushrod, the spring that helps basically